The piercing wail cut through the morning air over Warsaw like a demonic scream. September 1st, 1939. Citizens froze in their tracks as the sound grew louder, more agonizing with each passing second. Above them, black crosses marked the undersides of diving aircraft, Junkers 87 Stukas, their trajectory almost vertical as they plunged toward the city below. The siren mounted beneath each wing howled with increasing intensity, a calculated assault not just on buildings and infrastructure, but on the human mind itself. Polish soldiers who had never heard this sound before found their hands instinctively covering their ears instead of manning their defensive positions. Some broke ranks and ran. The psychological effect was immediate, visceral, paralyzing, exactly as its designers had intended. Sitting in his office 300 miles away in Berlin, aircraft engineer Dieter Hoffmann listened to the first field reports with grim satisfaction. 6 months earlier, he had stood in a wind tunnel at the Junkers factory in Dessau, Germany, making final adjustments to his creation, the Jericho trumpet, the most effective weapon of psychological warfare the modern battlefield had ever witnessed. As he reviewed the initial Polish campaign data, Hoffmann's notes confirmed what military psychology experts had only theorized. Sound could break morale faster than bombs. Men would stand against explosives, but flee from a noise that triggered something primal in the human brain. His face betrayed no emotion as he marked the results. Sound effect exceeds expectations. Terror impact calculable at 130% of projected estimate. What the Wehrmacht's top brass celebrated as a technological triumph, Hoffmann privately viewed with more complexity. The engineer had created a device that weaponized human fear itself, a scientific achievement that brought tactical advantages while revealing something disturbing about how easily the human mind could be manipulated. The siren represented not just German engineering precision, but a new frontier in warfare where the battlefield extended into the psychological realm. No one in the Luftwaffe's technical division understood that morning that one engineer's acoustic innovation would forever change how soldiers experienced combat, transforming the very sound of war into a weapon more feared than bullets. Dieter Hoffmann's path to creating history's most infamous aerial sound weapon began far from the military-industrial complex he would eventually serve. Born in 1910 in Kolberg, a quiet Baltic coastal town, young Dieter displayed an unusual sensitivity to sound from his earliest years. His father, a clockmaker whose workshop filled their modest home with the rhythmic ticking of dozens of timepieces, often found his son disassembling music boxes to understand their mechanical workings. He could hear imperfections in clockwork that even I couldn't detect, his father would later recall. The relationship between mathematics and sound seemed instinctive to him. After completing his primary education, Hoffmann pursued engineering studies at the Technical University of Berlin, specializing in acoustics and mechanical engineering. His university notebooks, later preserved in the Bundesarchiv, reveal his early fascination with the relationship between sound propagation and human psychological response. His 1931 thesis on acoustic resonance in enclosed structures caught the attention of several German manufacturing firms, but it was the Junkers Aircraft Company that secured his talents immediately upon graduation. Junkers initially assigned Hoffmann to their engine noise reduction team, tasking him with making their civilian aircraft quieter and more comfortable for passengers. His colleagues found him methodical, precise, and somewhat distant, a man who spoke more comfortably about frequency ranges and decibel measurements than personal matters. He could visualize sound waves in his mind, noted his department supervisor in a 1935 performance review. Hoffmann would close his eyes when testing new configurations, as though he could see the invisible patterns of noise moving through space. When the Nazi Party consolidated power in 1933, the gradual militarization of German industry accelerated. Junkers, like other major manufacturers, found its priorities shifting from civilian to military production. By 1935, Hoffman's department was reassigned to support the development of the Ju-87 Stuka dive bomber, an aircraft being designed specifically for precision ground attack operations. The Luftwaffe had particular requirements for this new weapon system, not just technical performance specifications, but psychological impact considerations that revealed the regime's understanding of modern warfare as a multi-dimensional endeavor. The origins of the Stuka Siren project emerged from an unlikely source, not from the traditional German military establishment, but from the psychological warfare theorists who had gained influence in the Nazi military hierarchy. By 1937, the Reich Ministry of Propaganda had compiled extensive studies on mass psychology, examining how emotions could be manipulated on both collective and individual levels. These studies found their way to Hermann Göring's desk, who, as head of the Luftwaffe, saw potential applications for aerial warfare. The Second Sino-Japanese War had begun that summer, and German military observers deployed with Japanese forces reported a curious phenomenon. They noted that inexperienced Chinese troops would often break formation at the mere sound of diving aircraft, sometimes even before bombs were released. This acoustic vulnerability represented a potential tactical advantage that Göring was determined to exploit. In late October 1937, a classified directive was issued to the Junkers Technical Division to develop a means to maximize the psychological impact of the Ju-87's dive attack profile. The directive landed on the desk of Ernst Udet, the World War I flying ace, who now served as director of the technical department of the Reich Air Ministry. Udet immediately recognized that this was not merely an engineering problem, but a psychological one. The goal was not just to create noise, but to craft a specific sound that would trigger primal fear. After consulting with several department heads, he personally selected Dieter Hoffmann to lead the project, impressed by the engineer's unusual background in both acoustics and mechanical design. The laboratory where Hoffmann perfected the Stuka's psychological weapon looked more like a musician's workshop than a conventional engineering facility. Located in a separate building at the Junkers factory complex in Dessau, the acoustics laboratory was purpose-built with sound-dampening walls and specialized equipment for measuring precise frequencies. By January 1938, the space had been designated as a restricted area, with access limited to Hoffmann's small team and selected Luftwaffe observers. The central challenge facing Hoffmann was deceptively complex, creating a sound that would trigger maximum psychological distress while functioning reliably in combat conditions. Early experiments focused on electronically generated tones, but these quickly proved impractical for field deployment. Electronic systems cannot withstand combat vibration or electromagnetic interference, Hoffmann noted in his project journal. The solution must be mechanical, driven by the very air the aircraft moves through. This realization led to the breakthrough concept, a propeller-driven siren that would harness the aircraft's diving speed to generate its terrifying wail. Hoffmann's team constructed dozens of prototypes, each tested in wind tunnels that simulated the conditions of a diving aircraft. The early versions produced sounds that were certainly loud but lacked the psychological impact the project demanded. Something was missing from the acoustic signature. Major Friedrich Schröder, a Luftwaffe psychologist assigned to the project, provided crucial insight after observing test subject reactions to different siren configurations. The human mind reacts most strongly to sounds that change in pitch and intensity, Schroeder reported after one session in March 1938. A constant tone, no matter how unpleasant, allows the brain to adapt. It is the modulation, the rising and falling, that prevents psychological adaptation and maintains maximum distress. Armed with this insight, Hoffman redesigned the siren to produce a distinctive falling and rising wail as the aircraft's speed changed during its attack dive. By carefully calibrating the siren's propeller and resonance chambers, his team created a sound that began at a relatively high pitch when the dive commenced, then descended into a bone-chilling howl as the aircraft accelerated, finally rising again as the pilot pulled out of the dive. This modulating scream made it impossible for listeners to mentally adjust or filter out the sound. The final design that emerged from Hoffman's workshop was remarkably elegant in its simplicity. Each siren consisted of a small propeller connected to a metal disc with cut-out sections. As air rushed through these openings during a dive, it created rapid pressure fluctuations, essentially turning the entire airframe into a resonance chamber that amplified the effect. The device added only minimal weight to the aircraft, while delivering maximum psychological impact. When production began in late 1938, the sirens were officially designated Jericho trumpets, Jericho trompeten, a biblical reference to the trumpets whose sound allegedly collapsed the walls of Jericho. The name revealed something about how the weapon was perceived by its creators, not merely as an engineering solution, but as a mythological instrument of psychological warfare that could break enemies without physical contact. Dawn broke over Warsaw on September 1, 1939. The people of Poland's capital went about their morning routines, many already anxious about the diplomatic crisis that had been building for weeks. Few realized that within hours they would become the first population to experience the full psychological impact of Dieter Hoffmann's acoustic weapon. At 7:45 that morning, air raid sirens began to wail across the city. Most residents had experienced air raid drills before, but what followed was entirely different. From the western sky, formations of Junkers 87 Stukas appeared, their distinctive gull wings silhouetted against the morning sun. As they approached their targets, railway stations, communication centers, and military barracks, the aircraft tipped forward into their characteristic 70-degree dive. What happened next permanently altered the psychology of modern warfare. As each Stuka began its near-vertical attack run, the small propellers on the Jericho trumpets began to spin, driven by the rushing air. The sound that emerged started as a high-pitched whine, but quickly transformed into a horrifying, otherworldly screaming wail that seemed to drill directly into the human nervous system. The acoustic effect was magnified by the formation diving pattern, with multiple sirens creating overlapping waves of sound that made it impossible to determine direction or distance. Stanisław Osimek, a Polish army lieutenant stationed near the Central Railway Station, later described the experience in his memoir. "We had been trained to maintain discipline under artillery bombardment and machine gun fire. Nothing prepared us for this sound. It bypassed all rational thought and spoke directly to something primitive, in the brain. I watched trained men who had sworn to defend their positions simply drop their weapons and run with their hands over their ears. I found myself unable to issue orders. My mind simply would not function under that terrible noise." The psychological effect was exactly what Hoffmann's laboratory tests had predicted. The modulating, inhuman quality of the siren triggered an instinctive fear response that overwhelmed rational thought. Civilians caught in the open during the attacks reported symptoms ranging from involuntary urination to temporary paralysis. Some described a sensation of the sound physically entering their bodies, a perception that acoustic experts would later confirm was not entirely psychological, as certain frequencies can indeed create physical resonance in human tissue. Back in Berlin, the first performance reports from Poland reached Hoffmann's desk within days of the invasion. The data confirmed that his creation was exceeding all psychological impact projections. The propaganda ministry immediately incorporated the Stuka's distinctive sound into radio broadcasts directed at other European nations, understanding that the psychological groundwork for future conquests could be laid through audio alone. The wailing siren had become not just a tactical weapon, but a strategic one, a sonic harbinger of the blitzkrieg that European leaders now realized could soon be directed at their own populations. As the Polish campaign continued through September 1939, the Jericho trumpet achieved something few weapons ever have. It created a psychological impact that outlasted and extended far beyond its physical destruction. Long after the actual bombing runs ended, survivors reported hearing phantom sirens in moments of stress, a form of acoustic trauma that military psychologists would study for decades afterward. The sound of the Stuka had etched itself into the collective consciousness of those who experienced it, creating a psychological wound that proved remarkably resistant to healing. May 10, 1940. The Western offensive began at dawn with simultaneous attacks across the Netherlands, Belgium, and Luxembourg. Stuka formations, now equipped with the improved Jericho trumpets, played a central role in the initial assault, particularly against forward defensive positions and transportation networks. The psychological impact, already documented in Poland, repeated itself on an even larger scale across Western Europe. Dutch military positions along the Grebbeberg defense line were among the first to experience the combined physical and psychological assault of the Stukas. Lieutenant Cornelius van der Meer, commanding an anti-aircraft battery near Utrecht, later described the effect on his men. "The sound paralyzed our entire battery. My gunners either froze in position or abandoned their weapons entirely. I found myself unable to issue coherent orders. The noise seemed to scramble the connection between thought and speech. We had been warned about this weapon, but experiencing it directly overwhelmed all preparation." The French military, which had studied reports from Poland and attempted to prepare its forces psychologically, fared little better when directly exposed to the sirens. A French infantry captain stationed near Sedan wrote in his field journal, "No training can adequately prepare men for this sound. It bypasses all rational defense mechanisms and speaks directly to the primitive brain." I watched veteran soldiers who had survived Verdun become utterly ineffective, covering their ears and seeking shelter regardless of tactical necessity. Civilian populations proved even more vulnerable to the psychological effect. In Belgian cities like Namur and Liège, Stuka attacks created panic that significantly hampered military movements, as roads became clogged with refugees. The distinction between physical and psychological casualties blurred, with many civilians requiring medical treatment for acute anxiety reactions despite suffering no physical injuries. Field hospitals reported treating patients for symptoms ranging from uncontrollable trembling to temporary deafness and speech impairment. Luftwaffe Colonel Manfred Richter documented the evolution of these tactics. "We have learned to use the siren as a force multiplier. Even when ordnance is depleted, we now conduct simulated attack runs, using the psychological effect of the sound alone to suppress enemy activity." A single Stuka with functioning sirens but no bombs can effectively neutralize an area for 15 to 20 minutes, a tactical advantage that requires no additional resources. The Battle of Britain marked a turning point for the Stuka and its psychological weapon. Beginning in July 1940, Luftwaffe planners deployed Stuka formations against British coastal defenses and shipping, expecting results similar to those achieved on the continent. Instead, they encountered a devastating reality. In contested airspace against determined fighter opposition, the Ju-87's vulnerabilities outweighed its psychological impact. The Stuka's diving attack profile, which maximized the siren's effect, required a stable, predictable flight path that made the aircraft highly vulnerable to interception. Royal Air Force Hurricanes and Spitfires exploited this weakness mercilessly, decimating Stuka formations during the Channel battles of July and August. On August 18th alone, known as the hardest day, nearly 40% of the Stukas committed to action were shot down. Gerhard Schroeder, A siren maintenance specialist with Stuka Siren II recalled the sudden shift in aircrew morale. After Poland and France, our pilots had developed almost a sense of invulnerability. The siren made them feel like psychological masters of the battlefield. Britain changed everything. Suddenly they were the ones experiencing terror as Spitfires tore through their formations. Many began requesting that the sirens be removed to reduce weight and improve maneuverability. The very weapon that had defined their identity had become a liability. By September 1940, the Luftwaffe had largely withdrawn Stuka units from the Battle of Britain, reassigning them to less contested theaters. This tactical retreat represented more than just an adjustment of air assets. It marked the first significant limitation of the psychological warfare approach that the Jericho trumpet embodied. Against an enemy with effective air defenses and psychological preparation, the terror weapon lost much of its power. Despite this setback, the Stuka and its siren found new applications as the war expanded eastward. When Operation Barbarossa launched against the Soviet Union in June 1941, Stuka groups were at the forefront of the offensive. Soviet troops, with no direct experience of the weapon, proved vulnerable to its psychological effect in ways reminiscent of the Polish campaign. However, this effectiveness proved temporary. By late 1941, Soviet forces had begun developing both tactical countermeasures and psychological resilience against the siren's effect. Training programs specifically addressed acoustic warfare, teaching troops to maintain discipline during diving attacks. Some Soviet units employed a simple but effective countermeasure: cotton wool soaked in water and placed in the ears, reducing the siren's penetrating quality without completely blocking necessary battlefield communication. A captured Soviet training document dated October 1941 revealed the changing approach. The German diving aircraft creates its effect through fear rather than accuracy. When troops understand that the psychological impact far exceeds the actual danger, the weapon loses much of its power. Maintain your position, continue your assigned tasks, and remember that the sound is designed to affect your mind rather than your body. This adaptation illustrated a fundamental limitation of psychological weapons. Their effectiveness diminishes with exposure and understanding. The human mind, given time and training, can develop resilience against even the most carefully engineered psychological triggers. What had seemed like an insurmountable advantage in 1939 was revealing itself to be a diminishing tactical asset by 1942. Recognizing this evolution, Luftwaffe planners began quietly removing the Jericho trumpets from Stuka aircraft during 1942. The decision was driven by multiple factors. The added weight and drag reduced performance, the psychological effect had diminished against experienced opponents, and the distinctive sound gave early warning of attacks, allowing enemy forces to take cover. By mid-1943, most operational Stukas had been modified to fly without sirens, though some units maintained a few equipped aircraft for specific terror missions against civilian targets or inexperienced troops. For Dieter Hoffmann, this phase-out represented a professional challenge rather than a setback. His division had expanded its work beyond the Jericho trumpet to explore more sophisticated acoustic weapons, including directional sound projectors and infrasound generators. A 1942 report from his laboratory noted, "The fundamental principles remain valid, but application must evolve." The first-generation acoustic weapons relied on novelty and surprise. Next-generation systems must bypass psychological adaptation mechanisms by targeting physiological vulnerabilities that cannot be overcome through training or exposure. The spring of 1945 found Dieter Hoffmann in a small laboratory near Berchtesgaden in southern Bavaria, far from his former Berlin facilities. As Soviet forces closed in on the German capital, he had been evacuated along with other specialists considered valuable to the crumbling Reich. The remnants of his acoustic warfare division, now reduced to 7 researchers and a handful of technicians, continued working on projects that had virtually no chance of affecting the war's outcome. Hoffman's personal notes from this period reveal a man grappling with the implications of his work as the Nazi regime collapsed around him. "The acoustic principles we discovered remain scientifically valid," he wrote in April 1945, "but their application has followed a trajectory I failed to anticipate fully. Sound as a weapon targets something fundamentally human, the relationship between perception and emotion. This realization comes too late to influence the work's direction." On May 3, 1945, elements of the United States Third Army secured the research facility. Hoffman and his remaining staff surrendered without resistance. Initial interrogation reports describe him as cooperative but reserved, readily explaining the scientific principles behind his acoustic research, while remaining evasive about its specific military applications. Within weeks, he had been identified as a specialist of significant intelligence value and transferred to the United States under Operation Paperclip, the program that brought German scientific expertise to America. Hoffman's arrival at the Naval Medical Research Institute in Bethesda, Maryland, in October 1945, marked the beginning of the Jericho Trumpet's second chapter. Working under the supervision of the U.S. Navy's Psychological Warfare Division, he helped American researchers understand the principles that had made the Stuka Siren so effective. His detailed knowledge of frequency ranges, modulation patterns, and psychological triggers provided the foundation for post-war acoustic research programs that would continue for decades. Captain Julian Reynolds, who headed the Naval Acoustic Research Program, noted in his 1947 assessment, Hoffman's contribution extends beyond the specific weapon system he created. His methodological approach to quantifying psychological response to acoustic stimuli has applications ranging from military deterrence to architectural design and industrial safety. We have essentially acquired not just the blueprint for a weapon, but an entire framework for understanding the relationship between sound and human psychology. By 1950, Hoffman had been granted permanent resident status in the United States and held a senior position at the Naval Research Laboratory's Acoustic Division. His work now focused on defensive applications, developing methods to protect personnel from acoustic weapons similar to those he had helped create. This reorientation seemed to provide some measure of personal reconciliation, as suggested by a rare personal comment in a 1952 research paper. Understanding the psychological vulnerabilities exposed by acoustic warfare allows us to develop countermeasures that restore human agency in the face of such weapons. The same knowledge that creates vulnerability can be redirected toward resilience. Meanwhile, the Stuka Siren itself had entered the realm of military legend. Though the aircraft had been scrapped and the physical sirens largely destroyed, recordings preserved the distinctive sound that had announced the Blitzkrieg. Military psychologists studying these recordings identified specific characteristics that made the sound so effective: the modulating frequency that prevented psychological adaptation, the resemblance to human screaming that triggered empathetic distress, and the Doppler effect created by the diving aircraft that made the sound seem to physically enter the listener's space. Korean war planners briefly considered deploying similar acoustic devices on American aircraft, going so far as to test prototypes based on Hoffman's designs in 1951. However, the project was ultimately abandoned, with military psychologists concluding that the psychological impact relied partially on cultural and contextual factors that could not be reliably reproduced in the new conflict. The weapon that had terrified Europe proved less effective against different populations with different cultural frameworks for interpreting sound. The story of the Stuka Siren and its creator raises profound questions about the relationship between technology, psychology, and ethics in warfare. From a purely technical perspective, the Jericho trumpet represented a remarkable achievement, a relatively simple mechanical device that exploited fundamental human psychological vulnerabilities with devastating effectiveness. As an instrument of warfare, it demonstrated how attacking the mind directly could multiply the impact of conventional weapons while requiring minimal additional resources. Yet the very effectiveness of the weapon forces us to confront uncomfortable questions about the boundaries of acceptable conflict. Physical weapons target the body, leaving the individual's essential humanity, their capacity for choice, their psychological integrity, theoretically intact. Weapons like the Jericho trumpet deliberately targeted these aspects directly, seeking to override rational thought and induce primitive panic responses that stripped away the distinctly human capacity for reasoned action under pressure. Contemporary sonic weapons, from the long-range acoustic devices used for crowd control to more sophisticated directed energy systems, trace their conceptual lineage back to Hoffman's laboratory in 1938. Though the technology has evolved dramatically, the fundamental insight remains unchanged. Sound can bypass rational defenses and speak directly to the primitive brain, creating effects that conventional weapons cannot achieve. Perhaps most disturbingly, the Stuka Siren demonstrated how effectively fear could be weaponized through careful engineering. By identifying specific acoustic properties that triggered maximum distress, Hoffman's team created a weapon that exploited something universal in human psychology: vulnerabilities that transcended cultural, linguistic, and political boundaries. This universality raises troubling questions about human autonomy in the face of weapons specifically designed to override conscious control. For those who heard it firsthand, the Jericho trumpet represented something beyond ordinary fear, a deliberate intrusion into the most private sphere of human experience. Survivors often described the sound as something that violated rather than merely frightened, suggesting a recognition that this form of warfare crossed boundaries that conventional weapons did not. The weapon attacked not just bodies, but the sense of self, the capacity for reasoned action that defines human agency. As we consider the evolution of warfare in the 21st century, with its increasing emphasis on psychological operations, information warfare, and non-lethal weapons, the story of the Stuka Siren offers both technical insights and ethical cautions. It demonstrates the potential effectiveness of targeting human psychology while raising profound questions about whether such targeting represents a form of warfare that diminishes something essential about humanity itself. The most lasting legacy of Dieter Hoffmann's creation may lie not in the specific sound it produced, but in the questions it forces us to confront about the boundaries of acceptable conflict. When warfare targets not just the body but the mind, not just physical survival but psychological integrity, what remains protected in the human experience? The wailing dive of the Stuka, with its carefully engineered psychological effect, continues to echo through these questions long after the physical weapon itself fell silent. Would you have approached engineering problems differently if you understood how your creations might be used? Would you have recognized the line between technical achievement and ethical boundary? Or would you, like many technical specialists throughout history, have focused on solving the problem at hand while leaving the larger questions to others? The sound of the Stuka's siren has faded from living memory into historical recordings, but the questions it raises about psychology, technology, and ethics in warfare remain urgently contemporary. Comment below and share this story so others remember what happens when the human mind itself becomes the battlefield, and what we risk when we forget the distinction between defeating an enemy and destroying what makes us human.